Whoa, there are a lot of people. I never had so many people in front of me. As a preparation for this talk, I had to write a small biography about myself. And it wasn't as easy as I expected it to be. So I took a look at the biographies of previous speakers, and I found that they were all CTOs somewhere or founders. And I questioned myself, what did I actually achieve? And well, I think this is the best thing I ever made so far. Woo! It's an app called Nudeuner, and it helps you to find the nearest kebab shop, no matter where you are. It's nice, right? Yeah, I came up with this idea after I went out several times in Amsterdam and I couldn't find a place to eat. Well, but today I'm going to tell you about something I'm also very proud of. I started working at Picnic after this big success of Nudeuner 3 months ago. And my parents still think I'm working at a regular supermarket. But as you can imagine, delivering groceries is not an easy challenge. And in order to solve this challenge, we built basically almost every system used to solve this problem ourselves. And myself, I'm working on the Runner app. It's not yet live, but it will be an app that guides better. That guides our runners to from the hub to our customers and to show which groceries they have to deliver. And this is how it looks like. It's built in React Native, and it's also pretty cool because it has dark mode. And before I started React Native development last year, I worked 3 years as an iOS developer, and for me it was super fun to start working in React. Just being able to build views by just changing something, press on refresh. It's super straightforward. Another thing that's super straightforward is working with JSON data. You probably all know this function. You can use it to parse your JSON into a JavaScript object, and you can use the JavaScript object throughout your whole app. This is possible because JavaScript is a dynamic type language, which means that if you have a property, it doesn't really have a type. It can be a number, and later it can be a string. And this is different for languages like Swift or Java, where it really matters what you put in your variable. If you declare it once as an integer, it can never be something else. So if you want to work with JSON data, you have to first properly parse it to a dictionary and then check if every value in the dictionary is of the right type, and then you can put it into a final object you can use in your app. But there's a catch, because if you use this JSON.parse function, you can get, later in your app, you can get an error like this. And I think you all have seen this error before. It can happen if you try to access a property of an object that is actually undefined. And in React Native, if you don't catch this error somewhere properly, it can even crash your app, which you don't want, of course. And something else that can happen is that your type you get from the backend is actually different than you expect it to be. So let's say you expect the backend to send you a Boolean, but in fact it's sending you a 1 or a 0. Then a check like this will not work, and it will, if it's a 1, it will just not pass, right? And this is what what happens if you don't catch this error. You will be thrown out of your app, and you'll see this ugly dialog. And people that download your app will probably remove it and never install it again. And for us at the Runner app, it's also a big problem, because if this happens to all runners at the same time, it means that a lot of deliveries will be late because they cannot rely on the app anymore and have to go back to the paper we're using for a backup. So to solve this problem, you can use something like TypeScript to actually define how your data looks like that is flowing through your app. An example to the left is an interface, and let's look at this example for a second, because I will use this later in the talk as well. So it's about an interface person. It has a name of type string. It has a property age of type number, and the property age is also optional, which means that it can be either undefined or a number. And TypeScript helps you during development by reminding you that if I try to access a property gender from the object, that it doesn't exist. It will show me gender does not exist on the interface protocol or on the person interface. This is nice, but it only solves the problem for you during development, because as soon as you run the app, your TypeScript, your types will be stripped away. It will just be running JavaScript. So we've been looking at a few solutions to check our data we're getting from the API during runtime as well. And I will now walk through them. So there are two actually, and I'll tell some positives and some negatives and where we actually went for. So the first solution is called JSON schema validation. And for JSON schema validation, you need a JSON schema, which is shown at the right. So this JSON schema represents the interface, and a JSON schema is nothing more than a definition of how your JSON should look like. What's nice about JSON schema validation is that there are tools to generate your JSON schema from your interface. But what's not so nice about JSON schema validation is that I might want to change the interface. I want to take out the name property, but I forget to regenerate my JSON schema from the interface, and it will still work. I will still validate my JSON, but against the wrong properties, because I'm still checking if name is actually inside the JSON payload. Another nice library or a way to check your JSON in runtime is by using something called JSON Decoders. And JSON Decoder is a principle where you have a function. It takes your JSON as an input. It will check if the JSON you put in conforms to the types you specify in the function, and will return the value with the right type if it's correct. Or it will throw an error, which you can use to actually handle it. And for this talk, I'll be looking at, there are several implementations of JSON decoders, and I'll be looking at the one from Vincent Driesen. Very nice guy. He's a Dutch guy as well. He should work for Picnic. We really like his library. To give you a small example how a JSON decoder works is like this. So we define the decoder first, and it is simply a decoder that checks whether the input is a number. If we use the decoder with an input of 24, that will be successful because it is indeed a number, so it will return the number. But if I put a string of 24 written out, it will not pass. It will throw an error and actually say me what I expected was a number, but it's not a number. So this is actually something this is something you can do something with, right? So let's look at it's a similar example. So now it's not just a number decoder, but it is wrapped inside an optional decoder. So that's also nice about decoders. They are composable. You can nest them into each other. And this decoder will check whether the input is either a number, or it can also be undefined. It's also successful. But if you put in a string again, it will still fail because you're only checking for undefined or a number. So let's get back to the interface I showed you previously. So this is actually represented in the decoder as the thing on the right. So it's checking whether the decoder is an object, It has a string, or it has a name of type string, and it has an age of type optional. And again, some examples. If I put in as the JSON payload an object with name Lucas and age 24, it will be successful. If you just put in the name, it will also be okay. But if I don't put the name, which is required, it will throw me an error and says that the property name is missing. And for us, it's really valuable to have an error like this, so we can, if something like this happens, we can, our delivery guys can contact us and say, yeah, I get this error in the app, and we can do something with it. But, oh no, wait. First, the positives and negatives about JSON decoders. So what's nice about them is that they are composable. And what's also nice about them is that output types are inferred from the function. So to give you an example, if I add another property called length to the person interface, but I forget to add it to the decoder, and I will later try to decode JSON and catch the person return value in a variable, it will actually notify me, yeah, this is never going to work because property length is missing in your decoder. So that's a nice feature. And what's not so nice about JSON decoders is that you're defining duplicate information, right? Because now we have an interface to maintain and a decoder to maintain, and they both contain the same info, like about which properties there are and what the type is. So I came up with a solution for this, which is the JSON decoder generator. And what it basically does is it takes your interface and it creates a decoder for it. And we're doing that using the TypeScript Compiler API. And you can use the TypeScript Compiler API to transform your source code file into an abstract syntax tree. And an abstract syntax tree is a node structure which represents the content of your file. So the tree below the interface is the actual node structure of the interface. So it has a source file, which has an interface declaration. It has two properties, of which one has a name is of type string and the other one is age type number. And what we actually want to do is to transform this syntax tree, abstract syntax tree, to a other abstract syntax tree, which represents the decoder. And later we can print that abstract syntax tree to a file and have a decoder available in our code. So what we're doing, we're using a recursive algorithm to traverse down the tree until we reach a leaf node, and we convert that to a node in the tree we're building up, right? So the first step is to convert the property at the left. Is this readable, by the way? Okay. So this represents the name property with the string decoder, and then we go to the right side of the tree, which represents the optional age. And as you can see, this one is similar. It only has one call expression more to represent the optional decoder. Both properties are wrapped in a object literal expression, which is then wrapped in an object. So it is an object decoder, so it checks if it's an object with name and age now. So the only thing we have to do is to actually wrap it into a variable. Oh, and the last image is missing, but it should be constant decoder equals. Okay. Ah, there it is. It is still there. So I will now show you how it looks in code, and I'll also give a demo about what it does. Okay. Let's check. All right. Is this readable? I can make it a big. Okay, I think it's fine. That's not fine? Oh, wait. Yeah, I want to do, oh, it's in presentation mode. Maybe I can zoom. Better like this? All right, all right. So I'll not go into too much detail, but I will just tell about the different steps. So we initialize this class with an input pod, which is the input pod of the interfaces, which contain the interfaces which we actually want to transform. And then the output file will be the file name of the file containing the decoders in the end. So what we'll do is we'll first collect all the files which are in the directory, and we'll create a TypeScript program, and this is where the fun starts. So we'll create a program for the files and create a type checker from the program, and a type checker is nothing more than an instance that knows how to get the type for a specific node. And then we call the function generate from outside, which will just look through the source files and see if there is a interface declaration. So it loops through the nodes, the nodes in the abstract syntax tree. And if it's an interface declaration, we call this function, which is called decoder for node, which is a switch statement that can handle all kind of nodes. So first it will hit the interface declaration. Decoder for interface is called. It will take all the members of the interface and create decoders for every. It will call the same function again, and we'll create an interface for a decoder for the property. So it will hit property signature. A property signature will have a type which will call number, which can be a number node or a string keyword. So this is really, it is not that complex as it may look like fully zoomed in, because I don't think it gives a nice overview at the moment. But it's not, it's I think less than 120 lines of code. It only does handle the interface and property signature so far. But I'll now show a real life example of what it can be later on. Okay. Let's zoom in again. So what I have here on the screen is two editors. One at the left is the input file, and to the right will be the result of the converted decoder. So currently it only contains a comment about don't edit it, this is generated code. But as soon as I start adding, how am I going to do this? I'll just scream really loud. Okay, let's create the same interface person. So I save it, and it will create me an empty decoder. Let's add a property. So I'll add first, no, let's start with age first. So it's a property of age number, and it will be added to the decoder as well. Then we can make it optional, and it will be wrapped into the optional decoder. Let's add the string. Will also be added, and we can do more, right? We can declare another interface called food, which also has a name of the food. Will also appear on the screen, and as you can see, there are currently no empty lines between the methods. That's still something I have to fix, but it's generated code anyway, so it doesn't have to look very nice. Then we can even favorite food. I say, okay, now the person interface has a property favorite food of type food. As you can see, the decoders are now switched around. And the reason is because the person decoder is actually depending on the food decoder. We can, I will do one last example. So we can also have a sport. And let's generate it real quick. And then we can say, okay, the favorite thing of the person Can be a union type of food. Can be either food or a sport. And that will also be reflected in the decoder. Okay, that's the end of the demo. Okay, I have one last slide. So currently we support all kind of nodes. I just published it, or I uploaded the project on GitHub. It is not yet published to NPM, but if you would like to use it, please give it a star. You will, or follow it at least, and will be published within a month probably.